So previously we have discussed according to the syllabus. You can see the syllabus here. In this syllabus we have discussed the first two lectures, that means the energy band theory, which is very important for the next analysis, every device analysis. So first of all, for the lecture 1 and lecture 2 we have discussed the energy band theory or the qualitative analysis, not the mathematical or the rigorous analysis. We have seen a very simple and effective way of how energy band, that means the conduction band and the valence band, is being created within any device. That means it can be metal, can be semiconductor, can be insulator. Every device has its conduction band, every device has its own valence band, and how these two bands are created with the help of different atomic structure. We have already discussed that point. Now today we will try to discuss the bonding forces, different bonding forces. You can see in the syllabus that the different bonding forces in solid, and if the time permits, next we will discuss the difference between semiconductor, insulator and metal with respect to their properties, different properties that the metal, semiconductor and insulator possesses, or it may be depending on the band gap of this metal. What is the minimum band gap energy between the conduction band and the valence band? The difference between the conduction band and the valence band, that is called the band gap energy. And we will also discuss the band gap energy between the metal, semiconductor and the insulator. Okay, and the next point in the next lecture also we will discuss the very important topic, that is the Fermi level, and what do you mean by the basic classification of intrinsic and the extrinsic semiconductor. So today the bonding in solid. Okay, now you can see that the topic here, the types of bonding in solids. Now there are three basic bonding, that is called the ionic bonding, covalent bonding and the metallic bonding. So these three are different type of bonding happens within the every solid. So bonding actually represent how the atoms in a solid are kept within a very attractive force. That means there always exist a attraction, force of attraction between the two atoms. That's why a solid structure is actually formed. If there is a very weak bonding between the two atoms within any device, that then it becomes, from the solid it becomes to liquid state. So that's why you must understand then within the every device there must be a interatomic force resides, and that's why the structure, if the force of attraction is very much strong, then the solid is actually formed, and if the interatomic force is very much less, then the liquid stage is formed, and if it is further reduced, then the gaseous state is being formed. So from that you can actually understand that why bonding in solid is actually important. Okay, so you can see in the screen there are three different type of bondings happens within a solid. First one is your ionic bonding, second one is your covalent bonding, and third one is your metallic bonding. So next we will discuss these three different type of bonding, and one by one we will see the structure and the example of different atom, that means the which type of material is actually associated with different type of this bonding. So next, the ionic bonding. Now you can see that the ionic bonding is the attractive force that is existing. I have already said that if there is two atom is actually resides, and there is, suppose this is one atom and this is one atom, okay, and this is one atom, there is a bonding force that exists between these two atoms, okay, and that force of attraction makes what is the state of the material. It may be solid, may be liquid, may be gas, and within the solid there may be three type of bonding. You can see that sub bonding. So in the case of the ionic bonding, the attractive force exists between two positive ion and a negative ion when they are brought into close proximity or surrounding. They are formed when atoms of different element lose or gain their electrons in order to achieve stabilize outermost electronic configuration. That means what is it is trying to say is that whenever an atom loses an electron, it becomes positively charged. Okay, and whenever an atom gains an electron, it becomes negatively charged. That means the charge of electron is actually negative. That's why it is said that whenever an atom gets an electron, it gets negatively charged, and whenever an atom loses an electron, it actually becomes positively charged. So if two atoms of this negatively charged and positively charged comes into close proximity, so there must be a force of attraction resides between these two atoms, and that is the basic building block of the ionic bonding. Okay, so you can see that in case of the NaCl, okay, all of you know the NaCl, that is the salt structure. In the case of the NaCl, this is the sodium and this is the chlorine. In the case of the sodium, it is loses an electron, become positively charged, and in case of chlorine, it is gaining an electron and it becomes negatively charged. So whenever this type of structure is actually formed, then there must exist a force of attraction between these two. Okay, so that's why there exists a force, and that force is actually makes this NaCl structure, and that is called the ionic bonding. Okay, that is the building block of the ionic bonding. Now you can say this is the ionic bonding is forms between a metal and a non-metal. Okay, sodium is actually a metal, chlorine is a non-metal. So ionic bonding characteristics is that it forms between a metal, it must be a metal and a non-metal, between a metal and a non-metal, and there is electron transfer from the least electronegative atom to the most electronegative atoms. And bonding forces, that means the electrostatic attraction. Why electrostatic attraction? Because I have already said in the outset that if one atom becomes negatively charged and one atom becomes positively charged, so from the law of static electricity we can say that there must exist a electrostatic force of attraction between the two opposite charged of ions. Okay, so that is the foundation step of the ionic bonding. Now the pure ionic bonding ideal case always exist covalent participation. So that is the ionic bonding. Now the properties of ionic solid. Now the solid which is formed based upon the ionic bonding force of attraction between the atoms is called the ionic solid. Example is NaCl. You can say that the ionic solids are rigid, unidirectional and crystalline in nature. It must be crystalline in nature. They have a high melting and boiling point, obviously. These are the characteristics of the ionic solids. Ionic solids are that type of solids which is formed, the force of attraction between the two atoms is due to the ionic bonding. That means the ionic bonding makes the atoms closer. Okay, so they have a high melting and boiling point, and the ionic solids are good insulator of electricity in their solid state and good conductor of electricity in their molten state. So that is the vital point in case of the ionic bonding, because in the case of the ionic bonding example solid is that NaCl, that means the salt, and you can say that whenever the salt is in their solid state, they does not provide any kind of electricity, does not pass any kind of electricity. Okay, but if you make the solid in the molten state, that means if you get some amount of water and get salt into it, then this is the molten state of the NaCl, and in this solution NaCl solution can a good example of a conductor. That means it can pass the electricity. whenever it is in the solid state, it does not pass any electricity. That's why it is called a good insulator in its solid state. But whenever it goes into the molten state, then it is an example of good insulator, and NaCl is the perfect example of it. And the second most vital properties of the ionic solid is that ionic solids are soluble in water. Soluble in water means you can say that in the case of the NaCl, if we pour the NaCl into the water, all of you know that how easily NaCl dissolve into the water. So from that you can say that NaCl are highly soluble in water, and all of the ionic solid in this category have the property that they can easily soluble in the water and slightly soluble in organic solvent. It has a high probability of soluble in water, and it is a very small probability in soluble in organic solvent. So that is the property of the ionic solids. So next is the covalent bonding. So covalent bonding is formed when two or more electron of an atoms in its outermost energy level are shared by other atoms. Okay, and the most famous example in the semiconductor category is silicon. Silicon structure is actually formed by atom sharing. In this bonding, stable arrangement is achieved by sharing of electrons. Covalent bonding is based upon the sharing of electrons rather than transfer of electrons. In the case of the ionic bonding, you can say that one electron is being transferred from one atom to the other. That's why static electricity, force of static attraction is formed between these two atoms, and that's why there is a solid structure is formed. But in the case of the covalent bonding, there is a no transfer of electrons. The first point is, in the case of the covalent bonding, there is no transfer of electrons. Okay, only sharing of electrons happens. Example is that in the case of the silicon or the chlorine molecule, sometimes a covalent bond is also formed when two atoms of different non-metals share one or more pair of electrons in its outermost shell, like water molecule. Now you will see in the example, you can see that this is the chlorine structure 1, 2, 3, 4, 5, 6, 7. Chlorine has 7 electrons in its outermost shell, 2 chlorine atoms. Now to achieve the stable state of any atom, all of you know that there must reside 8 electrons in its outermost shell. So if one atom gets 8 electrons in its outermost shell, so that atom is called stable atom. Now this chlorine atom has got 7 electron in its outermost shell, and this chlorine atom also gets 7 electron in its outermost shell. Now if 1 electron from each chlorine atom gets shared by 2 chlorine atom, then each of the, suppose these 1 electron from this side and 1 electron from this side as being shared, these 2 electrons are being shared by both these 2 chlorine atom. That means whenever this is shared, then 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons gets possessed by this chlorine atom, and 8 electrons also gets possessed by this chlorine atom. So there is a stable state. Likewise in the H2O case, there is the same case. Here you can see that in the case of H, 1 electron, but to get the stable state in the hydrogen, in the case 2 electrons must reside. So this is 1, 2, 3, 4, 5, 6, 7, 8 in the oxygen case, and in the case of the hydrogen case, if shared, then there must be 2 electrons. So also this is stable state is achieved by sharing of electrons, and this is the most famous example. This famous example is in the semiconductor industry is silicon. Now in the case of the silicon atoms, you can say that 4 electrons reside in the outermost shell of a silicon atom. Now these 4 electrons is being shared. This is the silicon atom 4 electrons, and these 4 electrons is being shared by again 4 with the 4 silicon atom. So this is being shared, it gets 2, again it is being shared with other silicon atom. So this 2, this is 2, this is 2. So at most 8 electrons, all of the silicon atoms, upon sharing the electrons with its residing silicon atom, all of the 4 residing silicon atom and neighbor silicon atom, then it gets 8 electrons in its outermost shell, and once it gets 8 electrons in its outermost shell, it gets stable. So the basic principle behind the covalent bonding is, if one atom get 8 electrons or the in the case of the hydrogen it is 2. So if one atom gets 8 electrons in its outermost shell, it gets stable, and if one atom does not get 8 electrons on its own in its outermost atom, that it is being shared with the other atoms. Outermost shell electron is being shared with other electrons atoms, and as a whole, by sharing process, all of the atom in a structure gets 8 electrons in its outermost shell and gets the stable state. Okay, so covalent bonding, solid properties. Covalent compounds are bad conductor of electricity. Okay, because all of the electrons of the outermost shell, 8 electrons, so no free electrons are available. So that's why the covalent solids are bad conductor of electricity, as there is no free electrons, so there is no electricity. And covalent compounds are low melting point and the boiling point. They are insoluble in water, and they are also soluble in organic solvent like benzene. And this is the in contrast with the ionic bonding. In the case of the ionic bonding, ionic solids are highly soluble in water and they are less soluble in organic solvent. But in the case of the covalent bonding, they are insoluble in water. They does not dissolve in water, but they are soluble in organic solvents. Okay. So these are the properties of the covalent bonding. So next is your metallic bonding. So in the case of the metallic bonding, it has been observed that in the case of the metal, all of you know that in the case of the metal is a very good conductor of electricity. So as metal is a very good conductor of electricity, so there must reside a huge number of free electrons to conduct the electricity. Okay. So as metal is a very good conductor of electricity, there must reside a huge number, you must remember, there must reside a huge number of electrons in its outermost energy level, and these electrons are very much loosely held by their nucleus. So thus metal may be considered as a cluster of positive ion surrounded by a large number of free electrons. So you can consider the metal is type of material which there is a nucleus, and within the nucleus there attached a electron or maybe the 2 electrons, and they are very loosely bound with the nucleus. So if we apply a very slight amount of voltage or the excitation across the two ends of a metal, then the metal conduct, this loosely bound electron gets free, and these electrons can conduct the electricity. And it is said that you can see here the metallic sea of electrons. In the case of the metals, there is a huge number of free electrons are available if we apply a slightly small excitation. The excitation may be in the form of voltage, temperature, anything. And these electrons, the vital point is these electrons are very much loosely bound with the nucleus. So that's why they can be free, they can be freed upon application of a very much small voltage. The very much excitation may be very much less. You must remember that. Now the properties of the metallic solid. Now the properties of the metallic solids are high thermal and electrical conductivity. Obviously, because electrical conductivity must be higher for the case of the metallic bonding, because they are a very good conductor of electricity, because there exist a huge number of electrons available to conduct upon application of a very low excitation. So that's why the excitation may be thermal, may be electrical. So if we apply that excitation, current conduct very easily. That's why the first property is right, that the high thermal and the electrical conductivity. Low melting and boiling point temperature. It has a very low melting point and the boiling point. Have a bright luster, and metallic solids are malleable and ductile. Okay. So that is the few property. First two properties are important. You can ignore the rest two, but the first two properties are important. In the next lecture, from the next lecture onwards, we will discuss the distinction between this is the starting point of the, if your device theory, that means the metal, semiconductor, insulator. Obviously semiconductors are dominant in the case of the electronic device, or any electronic device are made up of semiconductor, but you must know the distinction between these three to understand why semiconductor is actually very much important in the case of the electronics industry. So that's why from the next cut onwards we will discuss the distinction between metal, semiconductor and the insulator. Thank you.